Yeah. Today we'll finish 5.4b, yeah, the second half of that exponential and logarithmic equations. And then we will go to 5.5, where we learn some basic of mathematical finance. And my purpose is more into give you a better view about how to use money. It's the time value of money, and it is very, very applicable to life. It's more, you can say that what I will teach you after this 5.4 is it's more useful than what you learn for the whole semester. And I really hope that you can see it that way. Now, let's go back to this 5.4 then, 5.4b. Log equation. Log equation. Now we will have these two ideas to apply here. The first one is this: if you have log base A of blah equals to log base A of blah by 1 to oneness, then blah must be equals to blah. Okay, now with some extra note that both blah and blah has to be strictly positive. Basically, the argument, okay, once you solve it, you need to check if the x that you use to solve make the argument positive. If it is negative or zero, you have to exclude it. That's one. Second, if we have log base A of blah equals to blah, no logs, then the next step will be we rewrite it into exponential form. A to the blah equals, actually A to the blah equals blah. Okay, now don't forget that the argument still has to be positive. Just keep in mind that when you play with the argument in log, the argument has to be positive. Okay, now that's what we will employ here. Now let's see, for example, number 82, the easy one. Natural log of x equals to 1.6. Then to solve for x, I change this logarithmic form, becomes exponential form. The base is e, so x equals to e to the 1.6. Then you use your calculator. Okay? Can you help me with your calculator? And tell me what you get in 5 decimal places through the chat. What do you get? 4.95303. Good. 4.95. That's what I get also. 303. Okay. Now we call this the exact form. This is the approximate form. Okay. Now that's for 8.2. Use the same idea to do number 88. Similar idea. Number 88. We have log of 3z equals to 2. What will your next step be? You see this as a package, right? Okay, you see that as a package. What is the base? If you don't see the base, that's base 10. So 3z equals to 10 squared, which is 100, right? So c equals to 100 over 3. Now, if your answer is in fraction, you can just leave it like that. Okay, you can just leave it like that. You can make it decimal after this, but don't go to decimal without writing the exact form first. Okay, now that's for number 88. Let's go on with number 92. You see that implicitly the way we solve this log equation is to isolate the log, so that you have log on one side and constant on the other side. It's already log by itself on left hand side, constant on the right hand side. So I change it into exponential form. The exponential form will be square root of x minus 8 equals to e to the 5th. And then I square both sides. That's e to the 5th squared, which is e to the 10th, right? The power rule. And then I add 8. So x equals to e to the 10 plus 8. Now, I believe if you use calculator, the number will be quite big. So that's the exact form, and the following is the approximate form. Okay, this is the exact. This is approximate. Do you find it to be easy so far? Okay, let me challenge you to do number 96. Number 96. 2 plus 3 natural log of x equals to 7. Actually, I'm sorry, not 7, equals to 12. I give you 1 minute to do this. Go ahead. Okay, the key is to isolate natural log by itself first. Okay, so I will subtract by 2 and then divide it by 3. Now don't change it to decimal, because once you make it into decimal, very likely you need to do rounding. Sorry, that should be x equals to e to the 10 over 3. Now then, from there, you use your calculator. Okay, that's e to the power of parentheses 10 divided by 3. I get in 5 decimal places, that's 28.03162. Okay, this is the exact. This is the approximate. Now let's do harder ones. Let's say, for example, we see number 100. Number 100, natural log of x plus natural log of x plus 1 equals to 1. Now, the idea is if we have more than one logs on one side, okay, then basically you will make it into a single log using the property we learned before. Now, when I try to make it a single log, log of sum equals to, I'm sorry, sum of logs equals to log of products. Right? Now we have natural log of blah equals to 1. That's natural log of x squared plus x equals to 1. Then, using one-to-oneness, actually I change it into exponential form. So x squared plus x equals to e to the 1, which is e. Now I have x squared plus x minus e equals to 0. Now then, from there you solve it. I don't think we can factor this, and I don't think I want to complete the square because the coefficient of x is not even. So I will use formula. First, compute the discriminant. The discriminant is b squared minus 4ac, which is 1 plus 4e. That's the discriminant. So the solution x12 will be negative b plus minus square root of the discriminant over 2a. Then simplify a little bit, in this case just a little bit. Square root of 1 plus 4e over 2. Okay, now don't forget, in the past I said if you solve it using formulas, even by completing a square, I need you to split it. So x1 equals to negative 1 plus square root of 1 plus 4e over 2 and negative 1 minus square root of 1 plus 4e over 2. Now, we are not done yet. You need to look back into the log, okay? Make sure that the arguments are positive. Okay, now we have two solutions, right? The first one is negative 1 plus square root of 1 plus 4e over 2. Now, this guy here, let me use this one. This guy here is definitely greater than 1. Right? That guy is greater than 1. This guy is greater than 1. Why? Because 1 plus 4e must be greater than 1. So that when you do the square root, that's greater than 1. Now, something greater than 1 minus 1 will be positive. Now, of course, you can just use calculator to compute this also, right? Okay, now once x is positive, then it is fine here. And of course, when you add 1, a positive number plus 1 will still be positive. Okay, so I will accept this solution here. We have problem with the second solution though. If you see negative 1 minus square root of 1 plus 4e over 2, this is negative minus something will stay negative, right? Now that will make the argument here becomes negative. Actually, the second one also negative. Okay, but once the argument becomes negative, we have to reject that solution. Okay, once the argument is negative, we need to reject that solution. So I will go back and then explain it further. I'm sorry, I actually crossed the wrong one. I mean, this is okay. This one is okay. This one is not. Okay. In fact, it would be nice if you can summarize that. So x is equal to negative 1 plus square root of 1 plus 4e over 2. Okay. And if you wonder what's the reason, then you will see that natural log of x2 is undefined. Maybe I will say x2. This is because and you see that we have x2 and x2 plus 1 in the argument, right? The thing is this guy is negative. And of course, this one also negative. That's why we have to reject them. But if you have to reject once it's It doesn't satisfy the domain of any one of the log. Okay, so you see the problem here is actually not really with the we get a very ugly answer, right? It's more about the one that you need to be aware is that whatever solutions you have in a log equation, you need to check against the original argument. Okay, the argument cannot be negative, actually cannot even be zero. It has to be strictly positive. Okay. Now, how about number 104? Number 104, we have natural log of x plus 1 over natural log of x minus 2 equals to natural log of x. Now, what I will do on the left-hand side, I will condense them into one single log. That will be natural log of x plus 1 over x minus 2. On the right-hand side, we have natural log of x. Now you see that log equals log means the blah equals to blah. Then solve it from there. Okay, so multiply by the LCD, we get x times x minus 2, x plus 1 equals to x squared minus 2x, 0 equals to x squared minus 3x minus 1. Then from there, we solve. I think I need to, I think I need to do my formula. So b squared minus 4ac. When you multiply or divide, add, subtract even exponent of negative number, use parentheses. So this will be 9 plus 4, that's 13. Therefore, the solutions will be x12 will be negative b plus minus square root of 13 over 2a. That is 3 plus minus square root of 13 over 2. Now, from there, then you split it. Okay, 3 plus square root of 13 over 2 and 3 minus square root of 13 over 2. Okay, now make sure that it satisfies these things, that x plus 1 has to be positive, x minus 2 has to be positive, and on the other side, x has to be also positive. I'm talking about these three things here. This guy and this guy and this guy has to be positive when you plug them in. Okay, now of course you will see I don't need to plug all three in. All I need to make sure that is that the smallest one has to be positive. In this case, among these three, the smallest one is this, right? Okay, so your x has to be greater than 2. I wonder why my stuff changed. Why did that thing move? Okay, now of course another way you can do this is take a look on the approximate value. Okay, take the look on the approximate value. So use your calculator and then compute this. Okay, 3 plus radical 13, whatever the result divided by 2, I get this is 3.30278. And then the second one, 3 minus square root of 13, whatever the difference, divided by 2, I get negative 0.30278. Now notice that I wrote earlier that x minus 2 has to be positive or x has to be greater than 0, right? Therefore, I need to reject this one. I will accept this one. It is possible you accept both of them. It is possible you reject both of them. In this case, we only accept one of them. So x equals to 3 plus square root of 13 over 2. Okay. Now let me ask you to try question number 108. You do it. Number 108, that is log base 2 of x plus log base 2 of x plus 2 equals to log base 2 of x plus 6. Secondly, partition this first. And then once you're done with number 108, try number 110. Number 110, we have log base 3 of x plus log base 3 of x minus 8 equals to 2. Okay, try this. 1, 2, 3, 4, 8. Yeah, let me give you 8 minutes from now. So 11:45. Number 108, we have sum of logs on the left-hand side, put them together, becomes log of product. Equals to log base 2. Of course, when you put them together, make sure the base are the same. Okay, now on the left-hand side, log blah equals to log blay implies blah equals to blay. So x squared plus 2x equals to x plus 6. Set one side equals to 0. And oh, I can vector this. So x plus 3, x minus 2 equals to 0. I get x equals to negative 3, x equals to 2, right? Now, will negative 3 be okay? Why not? Yeah, the answer is no, but why not? Well, because negative 3, when you plug in here, it becomes negative argument, right? Okay, so I have to reject that one. We have to reject that one. How about 2? When I plug in 2, I think 2 is okay for this. Positive 2, positive 4, positive 8. Okay, so 2 is okay. Yeah, I will just underline them like this to say that's the answer. But don't forget, you need to cross out the one you reject. Okay, that's for number 108. Number 110, put them together, log base 3 of x times x minus 8 equals to 2. Then you change that into exponential form. So x times x minus 8 equals to 3 squared. Right? Log blah equals to 2, then blah equals to 3 to the 2. Now I get x squared minus 8x equals to 9. So x squared minus 8x minus 9 equals to 0. x minus 9, x plus 1 equals to 0, x equals to 9, x equals to negative 1. I think I have to reject x equals to negative 1. But will 9 be okay? Yeah, I think 9 is okay, right? 9 is okay. So the nice thing about this is you may just need to check that visually. Okay. The one earlier, I could not really check that visually until I actually get the numerical value. Then I can check that visually. Okay. Now, I will then go on to do problems that our textbooks say you need to use graphing software to solve it. But actually, no, you don't. You don't need to. Yeah, you don't need to. For example, number 116. Number 116, natural log of x plus 1 equals to 2 minus natural log of x. Then I move the natural log of x to the other side. Okay. In fact, we did this problem earlier, similar to this one earlier, number 100. Or question number 100. Or question number 100. What's that? Yeah. It's basically, but it's equals to 1. Right now, we have equals to 2. Okay. So the procedure will be very similar, right? This will be natural log of x times x plus 1 equals to 2 into exponential form. That's x squared plus x equals to e squared, right? So x squared plus x minus e squared equals to 0. Then you use quadratic form, right? But let's do the discriminant first. That's b squared minus 4ac, right? And then x12 will be negative b plus minus square root of the discriminant over 2a. Now then you go further, split them. The reason you split them so that when you compute by calculator to identify if this solution is okay with the argument or not, it's easier by finding the numerical value. Okay, now you will see that this one is okay, this one is not okay. Yeah, why? Because the natural log of x, the x has to be positive, right? Okay, let me summarize that. So x equals to negative 1 plus square root of 1 plus 4e squared over 2. So it's not hard, right? Now I will do 1 or 2 more problems, number 122 and then 120 and 126. Number 122. Number 122, negative x squared e to the negative x plus 2x e to the negative x equals to 0. And we need to solve this. Now, if you have your textbook, you will see that next to that part, they use this notation. They have a square and then they put the integral sign. Okay, it means you see this kind of question in your calculus for business class. In fact, in your calculus class in general. Okay, but they put it here not because it is a calculus question, but because when you are in calculus class, this is one of the skill that you need from college algebra or pre-calculus to continue answering that question. Okay, now, so what do we do here is this. We will solve by factory. Okay, we have common factor x and e to the negative x. So I factor those out. I get negative x plus 2 equals to 0. Now remember, the other side has to be 0 before you solve it by factoring. Now then, it means, notice that on the left-hand side of equal sign, it has three factors, either x equals to 0, e to the negative x equals to 0, or negative x plus 2 equals to 0. Is it right? E equals to 0, we are done. How about e to the x equals to 0, we are done. E to the negative x equals 0. You will say no solution for that one. The reason is e to the negative x has the range strictly positive. A to x, the value always greater than 0, strictly greater than 0, regardless the base is more or less than 1, as long as the base is positive. Okay, if we try, if we try to imagine the graph of e to the negative x, the graph of e to the negative x actually looks like this. It looks like this. The horizontal asymptote is y equals to 0, but still the range of e to the negative x is positive. So there's no such x to make e to the negative x equals to 0. Okay, and then for the last branch, you get x equals to 2. So for this equation, there are two solutions, and the e to the negative x is there just to annoy us. You don't like that terminology, maybe, huh? But it is true though, that e to the negative x is the one bothering you so much that, this is new, how to do this one. But after you work it out, you see that the e to the negative x just there to annoy you. Because the solution you have here, is the same to the solution for e negative x squared plus 2x. That's the same solution. Why? E to the negative x is always positive, such that if you factor it out, right, you can just ignore it later. Or you still need to show the work the way I do though, okay? But deep in your heart, you know, nah, that e to the negative x just annoyance, right? And yes, some people in our life just like that, okay? Yeah, some people in our life just like that. Try to find out that kind of people. And I don't tell, I'm not telling you to get rid of them. I'm telling you that, you know what, they're just, you have to go on with your life. Okay. The next one, number 126, seems to be very hard, but it's actually when I look at this problem, I was like, oh, how to do this one? But then what helps me a lot is the 0 on the other side. If that were 1 instead of 0, then it's so hard to solve. I don't think it's solvable by hand. But because that's 0, it becomes quite easy. Why? Because, like usual, if I have rational equation, I multiply by the LCD, right? So 1 minus natural log of x equals to 0. Basically, a ratio equals to 0 if the numerator equals to 0. But 1 minus ln x is 0 means 1 equals to natural log of x. And the next step is the Mickey Mouse one. You change it into exponential form. X equals to e to the 1, which is just e. Voila, you're done. Okay. Now, your suggested homework from this part, is 5.4b. I would like you to do number 81 to number 115, and then continue with number 121 to 127. Okay. Now I want to show you things when you study, when studying for test 4. you can look at Math 26 from SMC. Math 26 SMC. Now, of course, it's not on our campus, but it's with our, it is with our, my website. Let me show you. My website is harjuno.com. Harjuno.com, and then you click my name or my face, right? Now then, go to teaching, previous teaching. You have seen this before, right? Please don't tell me no. You have seen this before. I actually went over this on the first day of class. And you can see all tests here. Now, the thing is, because of the curriculum, your college algebra and college algebra from Santa Monica's college algebra, they call it Math 26, Functions and Modeling for Business and Social Science, which is basically yours. Now, the thing is, the first couple chapters of their textbook is differently arranged compared to your textbook. However, when it comes to their chapter, their test 4, the material for their test 4, they're actually already the same. Okay, so when I click this spring 19, I don't post anything there. We'll go to fall 17. Oh yeah, I have something there. So your test 4 will be very similar to this test 4. Are you looking at what I'm looking at here? I'm currently looking at fall 17 Math 26 test 4. Yeah. Okay. So you have material to study from there. Okay. Now you don't need to worry about that sequence series. I taught them that, but in my opinion, I won't do that for you in your class. Now, oh, by the way, before I forget, your test 4, notice that their test 4 is log and X, I think log, and then log equation and word problems about log and exponential functions. I will teach that to you on Tuesday, and you can ignore the sequence series. But for your test 4, you will have rational function also. Okay. Now, for you to find their rational function, you may need to look at their test 3. Their test 3 has rational functions. So you want to study this. Okay. You want to study this. And they have exponential function also there, the word problems. Okay. Solving these exponential equations. I do expect you to know that. And remember, you can always go back further. Oops. Oh, yeah. So you go back to fall 15. Hopefully I have some old tests to study from. Yeah, they're fall 15, test 4. Let's see. I wonder if we are looking at the same thing. Their test 4, they have exponential, which you will have, logarithmic, which you will have, logarithmic. Number 3, you will have that. Inverse function, you already have inverse, but at least you know you can study that for your final also, right? Okay, number 5, definitely that type of question will be there. Okay, on logs. So I'm teaching you about, okay, if you need to study from my old tests, if you need to study from my old tests, you actually have more than just Math 245 in my old test. You can also see Math 26 from East LA College. I mean, from Santa Monica College. Okay, and just keep on going back. That's fall 15, spring 15, test 4. Oh, yeah, well, you can see yourself. Okay, you can see yourself. Now let me go back to our class. I want to teach you some financial math. And This is more important. I say that this is more important than a kind of things that you learn in this course, because it affects your decision making in future. Okay, of course, one of the things I would like you to learn is, let me tell you first what we will learn here. What we will learn is our first one is uh, compound interest. Okay, basically, suppose I deposit amount of money A with interest rate R, and for time T, number of compounding N, then how much money I get at the end of T years. Let me define what's my A here. My A is the amount saved or deposited. R is the annual interest rate. The T is the time saved, time in deposit or in the saving, and then N, number of compounding. We also call that number of periods in a year. And this P here is the amount after T years. Okay, that's what we will learn today. And then on Tuesday, I plan to teach you installment. They also call that amortization. I don't like that the term amortization. Hold on. What is the better name for that? Give me a second. I suddenly forget the terminology. Not amortization. Annuity. 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 It has something to do with what we call sinking fund. Closely related. And then after that, then we can go into installmenting. Okay. I give you idea first what I meant by time value of money. And I hope, well, once we talk about this, you have more interest instead of like only me talking. You ask more questions too. Okay. And we have better discussion that way. An introduction. An introduction. Suppose I want to give you $1,000. Suppose I need to pay you $1,000 for a service that you provide me. Okay, let's say you help me doing something and then I need to pay you $1,000. My question to you is, do you want me to pay you $1,000 now, or let's say 2 months later? If you don't know the answer, you should drop the class and drop West LA College. You are hopeless. What's your answer? Would you like me to pay you now or 2 months later? Nobody say anything. Am I recording this? Yeah, I am. No, there's no tricky question here, just common sense. And I believe you should have common sense. If somebody wants to give you $1,000, would you like that now or 2 months later? Yeah, of course now, right? Yeah, of course now. Of course now. Now the question is why? Yeah, you may say because Thomas may run away, Thomas may change his mind. No, 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 no. I'm not changing my mind. No, I'm not changing my mind. Suppose I just voluntarily will give you $1,000 out of the greatness, kindness of my heart. Okay. Would you like it now or 2 months later? Yes, you and I and everybody with common sense will say, yes, give it to me now. But the reason is not because it's, well, yes, I may change my mind. I may die somewhere in between so that you don't get your $1,000. But even if all those are not true, one thing for sure is true, is the time value of money. Why? When I give you $1,000 now, you can use this $1,000 for a lot of options. At least you can deposit that. And you earn interest, right? Okay. And it's actually only one benefit of having that money now. One benefit of having that money now is you can deposit and get the interest, right? But actually with that $1,000 now, you have option of using it now. While if you wait until 2 months later, then even though you can claim that $1,000 is yours, you don't have the option to use it in any way, not even depositing it and interest. So you see that the time value of this money is getting that $1,000 in your hand right now is more valuable than $1,000 later. Does it make sense for now? I hope it makes sense. Now, I change the question then. Suppose I change it to you get, instead of say pay $1,000 right now, you get $1,000 right now or 2 months later, then the answer will be now. What about I change that a little bit? You get $1,000 right now or $1,010 2 months later. Now, this one is a bit harder. Depends on different people. Okay, but tell me what you choose. $1,000 now or $1,010 2 months later. Okay, nobody answered me. Don't worry, don't worry. This is a hard question. Let me make it a bit more extreme. Suppose I say you get $1,000 right now or $2,000 2 months later. Can you make that decision? Yeah, $2,000 2 months later. But why? Notice that your answer, $2,000 2 months later, is also my answer, but it may not be the answer for some other people. Okay, so it's not really about right and wrong at this point. It's about how much you can grow that $1,000. Okay, so for you and me, if you give me $1,000 right now, okay, I think I can grow that to maybe $1,200 in 2 months. Okay, if I invest it myself or use it for some capital to do some kind of small business, okay, in 2 months I can grow that by 20% only. So it's telling me that in 2 months it grows by 100%, becomes $2,000. then I rather you grow the money for me instead of I grow the money myself. Does it make sense? Right? So in this case, you and my situation, your situation and my situation are pretty clear that yes, if the choice is $1,000 right now or $2,000 in 2 months later, then $2,000 2 months later will make more sense. Okay. Now for me, for this question B here, $1,000 right now or $1,010 2 months later. So you give me extra $10 for 2 months later. I rather have it now. Why? I think with $1,000 right now, the flexibility I have that having the money right now, okay, the less amount of stress of because of short $1,000 short in these 2 months worth more than $10. So if you ask me $1,000 right now or $1,010 2 months later, I would say give me that $1,000 now. Okay, so you see we have between this guy and this guy, we start as having a number in which we are willing to trade that $1,000 right now or what number 2 months later. So let me rephrase the situation. Will this $1,000 right now equivalent to what dollars 2 months later for you? Can you tell me a number that with this $1,000 equivalent, this $1,000 right now is equivalent to what 2 months later? Again, it depends on different people, right? And what kind of job you have, what kind of business you have. If you are a student, actually, $1,000 right now and anything more than 1,000 2 months later is better later, as long as you give me more. Why? Because if I have $1,000 right now and my financial resource is actually okay for these 2 months without this extra $1,000, I rather you grow the money for me because with this $1,000 with me right now, I cannot grow it anyway, right? Okay, but if you are running business, then you ask yourself, what can I do with this $1,000 in 2 months? Okay, let's say if I'm doing business, then I may say, you know what, in 2 months, I can grow this money becomes 1,400 if I do it myself. Okay, now, so once you offer me $1,000 now or $1,400, 2 months later, I start thinking hard. You know what? I don't know. If you make it $1,000, $1,500  2 months later, I will let you grow the money. But less than 1,400, I will keep the 1,000 right now. So you say, so basically you are saying implicitly, you are saying that in your mind, let's say that's the setup, right? Okay. It means $1,000 right now for you is equivalent to $1,400 2 months later. So you see the time value of money? Do you see what I'm trying to say? The time value of money, right? $1,000 right now is not the same value with $1,000 2 months later. Numerically, they're the same. Okay, but when you put that money in your hand compared to putting that money in Thomas' hand, of course, it has different value. In your hand, you have more options, you have more things you can do with that money, and that $1,000 in my hand give me more option, not you. You see the difference? Okay, so at one point, as we increase this $1,000 to a certain number, let's say 1,400, then you start saying, you know what? If it is more than $1,400, then in these 2 months, I leave it in your hand. As long as 2 months later you give me more than 1,400. Okay. Now the thing is there any way to justify or to find out what number here should be for the population? I said earlier, it actually depends on each person, right? But if we want to see compared to the bank, then we see how much bank willing to grow to take your money for what kind of sacrifice. Because the way the bank think is this: they get your money $1,000 right now is better than they get the money $1,000 later, right? Okay, and they are willing to pay you some extra money if you let them use your $1,000. The question is then, what is the fair one for them, and how much you're willing to trade it for? Okay, now let's start with some idea how to compute. Suppose I give you foundation only right now, and then on Tuesday I make it big. Suppose the principal, the amount of money you put in, is $1,000, and the interest rate is, let's say, 6% a year. Now 6% a year interest rate is very high for America in United States, but that's actually low in Indonesia. Now, interest rate has a lot to do with inflation. The higher the interest rate, usually to overcome the inflation. Okay, so you don't like higher interest rate, you don't want inflation. Okay, but for people who are already retired, their income depends on interest rate for their retirement fund. So that's why younger generation, you and me, and older generation who already retired have opposite interests in this case. So saying that, well, the interest rate is so high, that's bad for the society, that's not true. It's bad for you maybe, but people who are retired, they want high interest rate. Why? Because their retirement grows with that interest rate. Okay? Younger generation, because what? We want to buy a car, we want to buy a house, right? Okay, when we buy a house, we will pay in installment usually, and for that reason, we want the interest rate is low. Okay, but those who are retired with their money in retirement, in their retirement account, okay, they don't want to work anymore. They already passed their time. They want to enjoy their time, right? Let their money grow. Okay, of course they want the interest rate to be high. Okay, now suppose then we say that the number of compounding is done 4 times a year. Now, how much money you have in the account after 2 years, let's say. I give you the scheme first. So right now you have $1,000, you deposit that. Okay. Now this 6% is the annual interest rate. Okay. In annual interest rate is 6%. But in 1 year, you compound it 4 times. Means the periodical rate, every time you do compounding, the compounding rate is 6% divided by 4, which is 1.5%. Can you follow me? So it means every 3 months, your money will grow 1.5%. Right? Every 3 months, 1.5% extra, 1.5% extra. So your money 3 months after you deposit that will be $1,000 plus 1.5% of that 1,000. Are you with me? Which, if I simplify, that's actually 1,000 times 1 plus 1.5%. Now, 3 months after that first period, your money will grow again. Grow by what? By 1.5%. Notice that the interest you get after the first period will get the interest again. So you have interest on the top of interest. That's what we call by compounding. Okay? So you will have how much money you will have? You will have the capital that you go into that period, which is 1,000 plus 1.5% plus 1.5% of that amount. It gets very complicated, huh? Don't worry, because that if you know your math, I'm sorry, should be times 1,000. 1.5% of that 1,000 times 1 plus 1.5%. In other words, the amount of money you have after the second period will be 1,000 times 1 plus 1.5% squared. So you see, when you jump one time, your money will be 1,000 times 1 plus 1.5% to the power of 1. When you jump the second time, it will be the power of 2. When you jump the third time, it will be the power of what? 3. The fourth time, so in 1 year at which you jump 4 times already, it will be 1,000, that's the principal, times 1 plus periodical interest to the power of 4. In 1 year. Notice that in 1 year you jump 4 times. Now in 2 years, how many times you jump? In 2 years, you will jump 8 times. Right? 2 years, you will 8 period. So the amount of money you have at the end of 2 years will be originally $1,000 times 1 plus 1.5% to the power of 8. Okay, now let's see the general formula. You can use calculator from there, but the general formula basically is the following. The money you have, let me call that PT, the money you have after T years is equal to the original investment times 1 plus the periodical interest, which is the annual interest divided by the number of compounding per year, to the power of how many times you jump. But the number of times you jump is n times t. N times jump per year times t in years. That's the formula. Okay, so going back to this story, suppose the initial amount is $1,000, right? And then the interest rate is 6% per year. The number of compounding is 4 times a year, and you will deposit it for 2 years. Then how much money you have at the end of 2 years? That would be 1,000 times 1 plus 0.06 over 4 to the power of 4 times 2. That's 1,000 times 1.00, actually 0.15 to the power of 8. That's how much money you have at the end at the end of these 2 years. Now, please use your calculator to compute that. 1.015 to the power of 8 first, and then multiply by 1,000. I get $1,126.49. I round it to only 2 decimal places because that's the 49 cents. Now, suppose I change the question. Suppose, for example, I pass away and then my son get the inheritance of $100,000. The interest rate, let's say, to make it more reasonable, make it 3%. Compounded monthly, twice a year, and he is currently 3 years old, and he will not use it until he reach 18 years old. So he will actually save that for 15 years. Let's say before I die, I told my wife, you know what, my insurance money, save $100,000 in this bank and make it under Peter's name, my son's name. and he can only use it after 15 years. Then how much money will he receive 15 years later? Okay, I'm talking about me, but eventually it is about you, right? Okay. If you have $100,000 right now, and you have the right to spend it now, or you have the option of depositing it for 15 years, would you like to know how much money you have at that time? And think about what kind of option you have at that time, what to buy at that time, compared to what to buy right now. Okay, so solution. Let me compute the periodical interest first. That's 0.03 over 12. That's 0.0025. And the number of period will be n times t, 12 times 15, 6 times 30, 180. So the amount of money my son has 15 years from now by depositing $100,000 right now will be 1 plus 0.0025. It seems to be a small number, huh? But you take it to the power of 180. 1.0025 to the power of 180 is 1.56743175. I don't do rounding because I know I will multiply by 100,000. So at the end of these 15 years, he would have had this much money in that account. So this $100,000 is, we can say, is equivalent to $156,000 something 15 years later. Now suppose somebody then asks my wife, hey, you know what? My company is trustable, but I need some cash right now. Can I borrow your $100,000 for your son? And 15 years later, I guaranteed you that I will give your son $200,000. Then you know the trade-off. The trade-off is at this number, 156,000 something in 15 years. If that person cannot offer you more than this money, I'd rather put it in the bank. In fact, if that person can offer me this amount of money, I tend to go with that person. Why? As long as that person do not report it to IRS, right? Okay, person-to-person loan, right? Because $56,000 that my son extra that my son received 15 years from now, it will be taxable, right? Okay, and I'm quite stingy. I try to save my money from IRS. They are the best thief of the world, right? Okay, before you get your money, they get their part first. They're the best. Okay, so if I can hide it away from IRS, I will do so. Okay, now another one. Let's change the question. On the other hand, suppose my son's need when he goes to college in 15 years later, when he goes to college, actually 14 years. I expect him to start going to college when he is 17 years old. Okay, let's say at that time, he needs to have $60,000. And the interest rate right now is 3%, compounded monthly. Okay, of course, the T is 14. How much money I need to deposit right now, how much money I need to set aside for him right now, and just leave that money in the bank for 14 years, and 14 years later, he can just use that money. Now the question is how much money I should put into the bank right now. So let's put in the formula. We know that the initial, the periodical interest is 3% divided by 12. That's the same number we have earlier, right? And then the number of periods, the number of times they jump is 12 times 14. That's 168. Okay, so This is the formula. PT equals to the deposit times 1 plus I to the power of NT. I need 60,000 in 14 years. How much I need to put in right now? Just put in that money and just leave it there. Now you will see this option is actually very heavy for me. So on Tuesday next week, on Tuesday, what we will learn is instead of doing deposit this money one time and leave it alone, I will pay it in installments. So let's say I tell myself, oh, you know what? For my son, education money, 14 years from now, I will actually set aside my income, let's say $500 every month from now for 14 years. And let's see how much money he had 14 years from now, if I paid in installment. But that's the story on Tuesday. Right now, this is the story. How much money I need to put in right now, such that 14 years later, my son has enough money, $60,000 according to my assumption here at that time. So I need to put in $39,443. Okay, now, so basically having $60,000 14 years from now is equivalent to $39,000 something right now. Okay, instead of waiting 14 years later and give him $60,000, you actually have an option to deposit $39,000 something right now for that amount 14 years later. Of course, when you put in $39,000 right now, you also trade with the bank your opportunity to grow that $39,000 on your own. Now, if you think you can grow your money better than 3% that the bank offer, then you grow it yourself, right? But if you actually say, oh, you know what, for the next 10 years, I will be at school or I will do something else, I cannot grow the money at that rate, 3%, then you let the bank does that. Okay, I hope this explanation makes some sense. Now, with that said, then I would like you to take a look on section 5.5. Number 15 to number 21. Okay, but there are 4 columns there. I want you to do just the first and the third and the fourth. So for example, number 16, right? You have $700, $750 right now. The interest rate is 10.5%. What is the amount after 10 years? Okay, just do these 3 columns. So skip column number 3. Skip column 3. You can do it actually if you want to. Okay, so this is the initial. This is the annual rate. Okay, and they say compound continuously. Now, if you compound it continuously, then the formula will be continuous compounding. Give me 1 more minute. Continuous compounding. Then the formula you use will be P equals to A. Actually, our textbook use different notation. Well, I use mine. So A e to the RT. Okay, you will use this formula if it is continuous compounding. Okay, I will stop here, and I hope you enjoy that exercise. It's again, it's actually good for you. Okay, see you then.